Hello students, welcome to the workshop on understanding building blocks of innovation. In this workshop, you will learn about the project design, sensors, output devices, controller units and coding. If you have an idea to create a new project, you should know how to design a product or a project. For that, you should know the major blocks of a product, which are input, brain or the controller, and the output. Talking about the input, it is the component which sends the external parameters and send the signal or the information to the brain board. The brain board or the controller board is the processor which processes the information received from the input and it will pass the signal to the output. The output reads the signal received from the brain and acts accordingly. In the human system, we have a brain which acts as a controller, and in electronic system, we have different types of controller boards like the sensor development board, TinkerSpace brain board, and the Tinker board robotic board. In human system, the inputs are eye, ear, nose, skin and tongue, whereas in electronic system, we have a lot of sensors like light sensor, fire sensor, temperature sensor, sound sensor, IR proximity sensor, rain sensor and soil moisture sensor. Talking about the output, in human system, mouth, hands and legs are acting as output units, where mouths can speak, alert others, shout. The hands can hold, open, wave or lift, and the legs can run, walk and climb. In the electronic system, we have outputs like red LED, green LED, buzzer, LED lamp, servo motor, transistor switch with DC motor, gear motor and the LCD screen. Let's see about the TinkerSpace lab input modules. First one is a light sensor. The light sensor is used to detect the light. Here, LDR or the light dependent resistor is the sensing element, and we can use this sensor in projects like automatic street light, headlight dim dip, laser fence and sun tracking solar panel. Next is a fire sensor. In fire sensor, IR photodiode is a sensing element. It detects the flame or the fire, and we can use this sensor in projects like fire alert system, firefighting robot and automatic fire extinguisher. Then comes the temperature sensor. In temperature sensor, thermistor is the sensing element. It is used to detect the temperature level and temperature of an object. We can use this sensor in projects like temperature controlled fan, engine temperature alert system, etc. This is a sound sensor where microphone acts as a sensing element. It detects the sound and detects the different level frequency of sound. It can be used in projects like baby cradle, clap switch, etc. Here comes the IR proximity sensor, which is used as an object sensor to detect the object within the range of 20 cm. You have to keep in mind that this sensor doesn't detect the black color. Transmitter or the LED emits the light, it hits an object and comes back, where the receiver or the IR photodiode receives the signal. In the case of black color, the black color absorbs the light, therefore the LED ray emitted by the sensor will be trapped inside the black color and the IR photodiode cannot detect the black color. We can use this sensor in projects like car theft detection, blind spot alert, suitcase security, watchdog alert and fast spinning game. This is the rain sensor, where parallel conducting plates act as the sensing element. It detects water drop and rain. We can use this sensor in projects like automatic wiper, smart cloth hanger, etc. Next is the soil moisture sensor. Here, two parallel conducting plates are used as the sensing element. It is used to detect the water content in the soil, and it also detects the moisture in any device. In the projects like plant watering alert, automatic irrigation system, we can use this sensor. We have the ultrasonic sensor, which is used to detect the object, and it can also measure the distance between the object and the sensor. In projects like height measuring cap, social distance alert, radar system, automatic lamp light control, distance meter, etc. Finally, the TSOP sensor or the IR remote sensor, which detects the IR remote signal or the TV remote signal. We can use this sensor in projects like light and fan control with TV remote, robot control with TV remote, gate open close with TV remote. Now, let's discuss the output modules in the TinkerSpace lab. First comes the LEDs. We have variety of LEDs like green LED, red LED, white LED and RGB LED. It is used in projects like road crossing system, traffic system, etc. Then we have the buzzer, which buzz or beep emitting a sound, and we can generate various music. This is used in projects for alerting or an alarm system, gift boxes, safety gadgets and gaming projects. Then comes the DC motor. The DC motor is a high-speed motor and the speed is 2000 RPM, but it has very low torque. It can be used in various projects which include mini fans, dynamos or mini robotic vehicles. Then we have the gear motor. which is low speed motors, only 100 RPM, but provides high torque. This is the motor used in robotic projects, lifting applications, trolleys, and for moving weights. Then we have the servo motor, which rotates till 180 degree. It has very high accuracy and we can easily control it with angle. It is used in projects like automatic gate open close, smart cradle, smart cloth hanger, smart solar panel, and radar system. Then we have the LCD display, which is a 16:2 display, and it is a type of alphanumeric display. We can use this output module in projects like Touch Me Not game, medicine reminder, left-right game, push-up counter, etc. Now we have the controller boards. Controller boards or the brain receives the information from the input and controls the output units. In TinkerSpace, we have mainly 4 controller boards. First one is a sensor development board. Using this board, we can make projects that doesn't require any coding. We can make projects by using this board in simple modes. We can make more than 20 projects that doesn't need any coding. This controller board is very easy to set up and it is recommended for age group of 8 to 12. More than 10 inputs and output units can be connected with this controller board. Next comes the Tinker Book, a controller in the form of a book. This controller board is specially designed for kids where we can make more than 40 projects including 20 no-code projects and 20 projects that involves coding. And the coding can be done using T-Code platform. This development board is recommended for the age group of 8 to 14 and it is very easy to build the models using this controller board. This controller board has got features like auto sensor setup, Wi-Fi and smartphone connectivity, and it can be connected with 15 inputs and output units. Next comes the TinkerSpace brain board. This brain board works with the coding and the coding can be done using T-Code and TinkerPy platforms. We can make unlimited projects using this brain board. It is very easy to build projects and it is recommended for the age group above 12. This brain board provides additional support like connecting ultrasonic sensor, IR remote, LCD screen, accelerometer, GPS, etc. Many mechanical projects can be made by using this controller board, especially motors like servo motors and DC motors. It includes Wi-Fi and smartphone connectivity, and we can have IoT applications using smartphone like opening a gate using smartphone, control the lift using smartphone, etc. We can connect more than 25 input and output units with this brain board. Finally, we have the TinkerBot brain board, which is a combination of TinkerSpace brain board with robotics applications. It includes all the features that the TinkerSpace brain board has. Additionally, we have the options for robotics and mini vehicles. This also supports Bluetooth and wireless connectivity, and we can carry out IoT applications like controlling a robot using smartphone. With this brain board, we can connect more than 25 input and output units. Now let's discuss the coding platforms that we use. We do the coding part to train the brain board. We need to give information to the brain depending on how we want to make the project. This training of the brain board is called coding. Coding is nothing but giving information to the brain board. It can be done through various coding platforms like C programming, C++ programming, Java, Arduino, Python, T-Code and TinkerPy. Now, let's see the difference between the conventional coding platforms and Tinker coding platforms. The conventional coding platforms are not designed for kids as it includes very complex coding. But in the case of Tinker coding platform, it is specially designed for kids from age 7 to 15. In the conventional coding platform, it needs expert coding skill for complex projects. Whereas in Tinker coding platform, all projects coding are made simple. The conventional coding platform includes complex coding structure and instructions, whereas Tinker coding platform has made the coding easier and fun. These conventional coding platforms need USB and programmer to upload the code, but in the case of Tinker coding platform, we can upload the code using internet. When it comes to conventional coding platform, we need complex hardware setup to build the robotics projects, wireless communication is complex, IoT application is complex, and finally we need a laptop or PC for coding. Whereas in Tinker coding platform, the hardware setup is made very simple. It also provides the easiest coding platform for robotics. It includes inbuilt wireless communication, in-app IoT application, and it doesn't need any laptop or PC. You can simply code using your smartphone. Here, we have learned about the project design, sensors, output devices, controller units, and various coding platforms. Stay tuned for more details.